let's go ahead and begin with identifying solutions to systems of linear equations in two variables. So we will be determining if the given ordered pair is a solution to the system. So the first thing we want to note is that x and y are given here as -3 and 5. So in order to be a solution to the system, -3, 5 has to satisfy both equations. I'm just going to go ahead and number these like I usually do, and we'll start with equation 1. We have 2 times a -3 plus 6 multiplied by 5, and we want to see if that's equal to 24. So we have a -6 plus 30 equals 24, and indeed 24 does equal 24. So we're good with equation 1. Now we also have to satisfy equation 2. So here we have x, which is -3, plus 5 times our y value, which is 5. And we want to see if that's equal to 3. So we have -3 plus 25, and we want to see if that's equal to 3. So 22 is not equal to 3. Okay? So therefore, -3, 5 is not a solution of the system. Okay? So we will just go ahead and square that answer off. Okay? Let's go to our next problem. This is number 2, and we're given 0 and 1/2. So here x is 0 and y is 1/2. Okay? Let's label these equations number 1 and 2, and I'll just start with number 1. We have 5 times 0 plus 10 times 1/2, and we want to see if that's equal to 5. Anything times 0 is 0. 1/2 of 10 is 5, and 5 is indeed equal to 5. Let's go ahead and look at equation 2. We have 22 times 0 minus 6 multiplied by 1/2, and we want to see if that's equal to a -3. So anything times 0 is 0. So we have a -3 is equal to -3. So 0, 1/2 satisfied both of these equations. So we can say that 0, 1/2 is a solution to the system. Okay? Okay. So let's go down to looking at the graphs of the equations in our system. That might help us a little bit. Just trying to move that up. Okay. Let's go down here. And we'll begin with number 1. Possible outcomes for solutions of a system of equations. There are only 3 outcomes. The first outcome is to have one unique solution, okay? And what those look like, well, it could be just any 2 lines. So you could have maybe this line, and then you could have another line go through like that. And then those 2 lines in the system, and you could put arrows on here because the lines have domain and range of all reals. So this point of intersection here, and I guess you could call that 1, 1, 2, 3. So you could say 1, 3 is the solution. Okay. The second case is no solution. Okay. And when you have one solution, you will have an ordered pair for your solution. When you have no solution, you will have the empty set as the solution. And these are called inconsistent systems. And what happens? What do these systems look like, the equations in these systems look like? Well, these are parallel lines. So there's no point of intersection. And when the equations in the system are parallel, when you graph them, there is no solution, so our solution is the empty set. And we call that an inconsistent system. I might also mention over here, this is a consistent system. Okay, let's go to number 3, infinitely many solutions. So you go to graph your, and it can be any line. I shouldn't draw them all looking the same way. Graph one of your lines in the system, and you go to graph the other line, and it is the same line. I'm going to kind of make it look like this. And these are the same line. So how many points of intersection do they have? Infinitely many solutions. So there are infinitely many points of intersection. Okay? We call these dependent systems, and these are the same line when they're graphed. Okay, let's talk about our methods for solving systems of linear equations in 2 variables. The substitution method is nice because you can isolate one variable and substitute it into the other equation. For the addition method, we're actually going to add the equations together and eliminate a variable. And then we will solve for the other variable. Let's give this a try. So the addition method means we are going to add these up. Now, if I add these 2 equations up, I'm not going to eliminate a variable. So I'm going to look for a plus and a minus sign if possible. And I like that I could multiply this equation by 3. Because if I multiply, let me just delete that real quick. If I multiply this second equation by 3, let's see what happens. So here's my first equation, here's my second equation. I'm going to go ahead and write these down again. So 2x plus 3y equals 10. Now 15x minus 3y equals a negative 78. So now look what happens. If I add these 2 equations together, I will eliminate the y variable. So what I have now is, I wish I could see all these different colors. What I have now is 17x, we don't have any y's, are equal to a negative 68. And if you divide both sides by 17, we get x equal to negative 4. Now this is good news. We have solved for one of our variables. Okay? So now we can go into either equation to solve for y. I don't know, I'm just going to pick equation 1. So we have 2 times our x plus 3y equals 10. So we have a negative 8 plus 3y equals 10. We will add 8 to both sides, divide both sides by 3. We end up with y equal to 6. So our solution to the system is an ordered pair, negative 4, 6. Now look over here what we have. This is equation number one of the equations, and this is the other equation, and these are both graphed. And I think this is going to be equation 1 with positive slope, and this is equation 2, because equation 2 Actually, equation 2 has the positive slope, so I just have these backwards. So that's equation 2 and equation 1, just in case you would put those in your calculator. And look at this. Look where those two lines intersect. The point, the lines intersect at this point, -4, 6, which is exactly what we got. Okay, moving on, let's go ahead and take a look at what we're going to have now. Solve the system by the addition method, okay? Addition method says we're going to add these together to eliminate a variable. I cannot do that right now, but I notice that I have a plus and a minus. So now, if I multiplied this first equation by a 2 and the second equation by a 3, I would have a 6y and a -6y, and that is going to work out for us. So let's go ahead and do that. Actually, I can come over to the right-hand side and do it. 4x plus 6y equals a -2. All I did there was multiply every term in the first equation by a 2. Let's do the same here for the second equation. 9x minus 6y equals 54. So I multiplied every term in that second equation by a 3. So now look what happens. When we add these together, we will eliminate that y variable. So we end up with 13x equals 52, and we have divide both sides by 13, and we get x equals 4. Okay, so there's one of our variables solved for. Now I can go into either one of these equations to solve for y, as I said before. So let's just go ahead and label this one 1 and this one 2. So I'm just going to go back and do equation 1. 2 times 4, that's my x, plus 3y equals a -1. 8 plus 3y equals a -1. 3y equals a -9, and y equals -3. So now our solution is 4, -3. Okay, moving on to number 3. Here we are going to be solving by the substitution method. So here we want to look for a variable that is easy to isolate. What I first notice right away is this x right here. It's already isolated. So using this equation, if I added 2y to both sides, I would have x equals 1 plus 2y. So now I can go into equation 1, and everywhere, I'll go ahead and write that whole equation out. But everywhere there's an x, I'm going to write a 1 plus 2y. Now, of course, there's just one x in that equation. Let's go ahead and distribute that 4 and add our like terms together. So 4 plus 5y equals 14. And we have, subtract 4 from both sides, 5y equals 10. And we have y equal to 2. Okay? Okay, now we are going to go back into either equation, and personally, we could use this equation right here. So let's go ahead and use that. X equals 1 plus 2y, 1 plus 2 times our 2, and we have x equal to 5. So now our solution is 5, 2. And as you can see, if you let x equal to 5 and y equal to 2, you also satisfy the first equation. So we have 20 minus 6 equals 14 when I let x be 5 and y be 2. And the same here. 5 minus 4 is 1. So it works out really nicely. Okay. Now we're going to use substitution method. If you can remember, what we were looking for was how to isolate, or if we had a variable that was isolated. And we right away see that y is already solved for. So equation 2 already gives us that y is equal to 5x minus 7/4. So now let's go into equation 1. 2x plus 4. Instead of our y in this equation, we're going to put 5x minus 7/4, and that's equal to 4. So now we have 2x plus 20x minus 7 equals 4. So 4 times 7/4 is 7. And then we have 22x minus 7 equals 4. 22x equals 11. And dividing both sides by 22, we get to 1/2. So we're in good shape now. So we're going to take x equal 1/2, and notice equation 2 is already solved for y. So y equals 5 times our x, which is 1/2, minus 7/4. So y is equal to 5/2 minus 7/4. Now remember that 5/2 is 10/4. Okay? Excuse me. Yes. So 10/4 minus 7/4 is equal to 3/4. So now we have a solution to our system, and that solution is 1/2 3/4. That is our ordered pair. Okay, let's go on and look at this next problem. Special cases of solving systems. Okay, so let's look at this. Now they don't tell us what method. You might right away see if I added these together, I could eliminate a variable. Okay, let's go ahead and do it. X minus x, well, that's 0. Negative y plus y, well, that's 0. 4 plus 6 is 10. So 0 equals 10. 0 does not equal 10. This is a false statement. And whenever you arrive at a false statement, 1 equals 5, anything like that, then there is no solution. And you might be able to write no solution as the null set. You may see that. And I'm just going to mention that this is an inconsistent system since there is no solution. Let's look at number 2. Right away we can see that in number 2, y is already solved for. So why don't I mention here addition method, because we noticed that would work nicely for that problem. And here we're going to use substitution because that looks like it's going to work well. I can see a variable already substituted for. So here y is 2x minus 6. So now what I'm going to do is I'm going to go into equation 1, 10x minus 5 times our y, which is 2x minus 6, equals 30. 10x minus 10x plus 30 equals 30. So 10x minus 10x is 0. 30 does equal 30. So what did we arrive at? We arrived at a true statement. 30 is equal to 30. And so we have what we call infinitely many solutions. And how we write these solutions is, do you see how y is solved in terms of x? So we can write x and then y in terms of x. And you can do that for either variable. So that is our solution. X, 2x minus 6. X, y. Also, why are there infinitely many solutions? For any x value, you give any x value, you can compute a y. So let's say if x was 1, y would be 2 times 1 minus 6, or 1 negative 4. 1 negative 4 is going to be a solution. Okay, let's take a look at solving systems with 3 equations and 3 unknowns. There are 2 big steps here. The first step would be to use 2 equations to eliminate a variable. Then we're going to use 2 different equations, and a different set of equations. Use a different set of equations. It's probably better to write that. And we want to eliminate the same variable that we just eliminated. Okay? And once we do that, then you will see, let me just get this written a little bit better, to eliminate the same variable. I think this eraser is pretty big, but I think that's okay. Okay, to eliminate the same variable. And then from there, I'll show you what to do. So let's label these 1, 2, and 3. And what do you notice? You see this plus y? No, look, this minus z and this plus z, that's what we're going to do. We are going to eliminate z with equations 2 and 3. Okay, so 2x plus y minus z equals 2, and x plus y plus z equals 2. We're going to add those together, and as you can see, the z's are eliminated, and we have 3x plus 2y equals 4. Now, we need to find a different set of equations. So since we use 2 and 3, we could use 2 and 1, or we could use 3 and 1. Okay, so 1 has to be used. Let's take a look at those. Here's 1, and here's, I like this negative sign. So all I'll have to do is multiply the second equation by a 6, and I'll be able to eliminate z again. So we are going to use equation 1 and 3, and let's go ahead. Would that be 1 and 3? Excuse me, 1 and 2. And that is a different set. So that's 3x plus 9y plus 6z equal to 3. And we have this equation multiplied by a 6. So let's see what we have. 12x plus 6y minus 6z equals 12. So you can see that we did eliminate the same variable. So adding these up, we have 15x plus 15y equals 15. Let's divide every term by 15. X plus y equals 1. So I'm going to call this equation 5 and this equation 6. So we're going to use 5 and 6 and see if we can eliminate a variable. So let's go ahead and write them down first. 3x plus 2y equals 4. 15x plus 15, oh no, let's just use the simplified one. X plus y equals 1. Okay, so let's take a look at this. What if I kept this equation, 3x plus 2y equals 4? And what if I multiplied this equation 6 by a negative 2? Let's see what happens. Negative 2x minus 2y equals a negative 2. So now when we add these together, we see that we've eliminated the y variable. And we end up with 3x minus 2x. Well, that's just x equals 2. So we have our first variable solution. Now, what do you notice? We have equation 6 that says x plus y equals 1. So if x is 2, y is negative 1. So all I need to do is solve for z, and let's go use equation 3. All three variables added together equals 2. So equation 3, x plus y plus z equals 2. 2 minus 1 plus z equals 2. 1 plus z equals 2. And now we have z equal to 1. And we finally have our ordered triple. And that is 2, negative 1, 1. And that is our solution. Let's try that one more time where we have an ordered triple as a solution, and we will end this lesson. So let's label these 1, 2, and 3, and we first pick a pair and look at the y in equation 1 and 3. So we will use 1 and 3. So we have 4x minus y plus 3z is a negative 2. And we have a negative 2x plus y plus 4z equals 14. And if I add these together, you can see that the y's cancel. And we have 2x plus 7z equals 12. Oops. And I'm going to call that equation number 4. Now we have to go find two other, another set of equations. I like this minus because we have to eliminate the y. So let's go ahead and use 1 and 2. But what we're going to do is we're going to multiply equation number 1 by, to eliminate the y's, we would need a 5 there. So let's go. 20x minus 5y plus 15z equals negative 10. And we're going to just write equation 2 down. 3x plus 5y minus z equals 15. So now when we add these up As you can see, we eliminated the same variable. We eliminated y. We end up with 23x plus 14z equals 5. And that is equation 5. Okay? So, let's go ahead and combine 4 and 5. So we have 2x plus 7z equals 12, and 23x plus 14z equals 5. Now we have to eliminate one of the variables. Notice the 7 and the 14. What if we multiplied this first equation by a negative 2? Let's see what would happen. A negative 4x minus 14z equals a negative 24. 23x plus 14z equals 5. So when we add those up, we did eliminate that z variable, and we end up with 19x equals negative 19, and we finally solved for our first variable. So now we will go back into one of these equations that just have x and y in them, and you can see clearly it would be maybe equation 4. And we have 2 times our x of negative 1 plus 7z equals 12. Negative 2 plus 7z is 12. 7z is 14. And we have our second variable solved. Z is equal to 2. Now we will go back into one of our original equations. You can pick the one you like the best. I think they're all about the same. So I think I'm just going to go into equation 1. 4x minus y. So let's go into equation 1. I'll just write it first. 4x minus y plus 3z is equal to a negative 2. So here we have x equals negative 1 minus y, which is what we're solving for. 3 times 2, which is our z, equals negative 2. Negative 4 minus y plus 6 equals negative 2. Negative y plus 2. Negative y equals negative 4. And y is 4. So finally, we have our solution. It is an ordered triple. X is negative 1, y is 4, and z is 2. And that concludes this video.